Our project is product improvement design for cervical orthosis for Torticollis, and our sponsor is LifeScape. So what is Torticollis? Torticollis is a congenital disease characterized by asymmetric posturing with the head most often tilted to one side and turned to the opposite side. This affects around 16% of newborns. Infants typically undergo physical therapy treatment before any other options are considered, and these three options being cervical orthosis, Botox injections, and surgery. So why are we working on this project? Left untreated, torticollis can result in permanent loss of neck mobility, pain, negative head shape changes, scoliosis, vision changes, deficits in vestibular system leading to impaired balance, or delayed and asymmetric gross motor skills. So what is cervical orthosis? Cervical orthosis is classified as a collar or post orthosis. It's used to protect and immobilize the cervical spine. When physical therapy is insufficient, typically a tubular orthosis for torticollis or a taut collar is suggested. The current taut collar is difficult to use due to the design of the product. And then Botox or surgery is considered when there's insufficient improvements or development of muscle contracture or pain from the collar. This is the current taut collar. It's one long PVC tube that connects on the left side right under that snap button connector. It also has paired tubes or struts, and these struts range in sizes from 1 inch to 2.5 inches, and this is the main support piece for the neck to keep it in place on the one side, and then the other side is left free to bend. So the way they currently test the current collar, they track the percentage of the time the child's head is held in midline. They also measure the degree of lateral flexion the child rests in when not in midline, both when wearing the taut collar and when it's removed. This is to help keep them in midline after weaning from the collar. And then they also track cervical extension and flexion, but these are secondary outcomes. They also use a muscle function scale, and this is to measure strength on each side of the child's neck, as you can see in the image below. This is our decision-making matrix. We scored the current product, Botox, and surgery based on 5 different aspects. This was taken from surveys as well as occupational therapists at LifeScape. We also tallied their scores, and then we had an estimate on our design, and we hope to improve each one of those qualities while increasing the overall effectiveness. So our goals are to improve the adjustability, cost, and aesthetics while maintaining effectiveness, comfort, and flexibility. And the main constraints, we're focusing on the age range of 3 to 4 months to 3 years old, and all staying within a $300 budget while building a few prototypes and a final design.
So for the adjustability connection methods of the circumference of the neck, we came up with 3 ideas. First being the hook and loop fasteners. They're relatively inexpensive, and the connection method would be pretty easy since the material can be cut through easily. Some cons may be that they're flimsy and they break easily, and the material used would be a Grip brand polypropylene webbing. This is due to the fact that it's heat resistant, and it causes that would aid in comfort. The second mechanism is a cinch strap. It is also relatively inexpensive, and the only bad thing about it is that the attachment method to the actual tubing may not be secure enough. And then the third mechanism used would be a trilateral hook loop mechanism. Essentially, it would be a 3D printed part, and the strap would be weaved through the holes. Essentially, it's similar to the mechanism of a backpack. You would pull on it to tighten the circumference, and you would kind of release it to expand the circumference.
For our new strut pieces, we want them to be adjustable, and in order to adjust the strut, we're going to use a twisting screwing mechanism to make the device longer or shorter. The new piece will also utilize a square attachment point to the T-joint in order to prevent unwanted twisting and adjusting when assembled. So what's next for our strut design? We want to expand on the current size. Right now we have one 1 inch to 2.5 inches, but we would like to expand that range to fit the age range we are looking to cover. We also need to design a new T-joint connector with a square attachment point. For material, we are going to be using likely PLA, as this is going to be 3D printed and that's the most common. Given we're 3D printing though, we have the option to test other materials and really hone in on the properties that we would like to see out of our struts. And then one of our main goals for these new struts is to ensure that they won't cause discomfort to the child's neck if it rubs up against the child's skin. If there's any questions or comments, feel free to contact us. And we also just want to thank our sponsor, LifeScape, for giving us the opportunity to work on this project.